All right, let's take a look at this one. Let's take a look at this one. To be fair, I wasn't listening to your conversation, so I was kind of assuming I didn't. So let's take a look at this. This is very much what we did yesterday. How are we going to start this? Let's start with when k equals 1. What is our value when k equals 1? 3. Because it's 3 to the first, which is 3.
Wait, that 3 on top of the something, like how many we define?
That's when we stop. So we start here, we stop here. Start when k equals 1, we stop when k equals 3. Yeah, so when k equals 2, that's when we get 3 squared. So we get 9. And when k equals 3, that's 3 to the third.
255. Whoa.
27.
Was I close?
Nope. Sum. I'm pretty sure you did a product.
Your answers are extraneous.
So we need the sum. Add them.
36?
39. 39. Sorry, I had to think it is when I just put in here quickly. I know, sometimes it's because I'm thinking, because I didn't actually pre-make this one. Yeah, it's 39. Oh my gosh, this pop socket just keeps like breaking. There we go. What's up? Okay, Bohemian Rhapsody. I was like, I know that song. It's an epic song. Okay, questions on this one? We're going to do 2 more like this, practicing the summation part.
Yay. I don't want to do 6 of these.
That's okay. We can do it.
2, 7, 9. Right?
I don't think it's 9.
Oh, no. Oh, sorry. 2, 5,
There we go.
9,
8.
8.
2, 5, 8, 11, 14, 17.
I'm still going to write things down because for a lot of people, it's going to sound like you are just randomly making up numbers. All right, so when j equals 0, that's our substitution. We're putting it into our rule up here. So we're doing the sum from j equals 0 to 6 of 3j plus 2. So we're going to take 3 times our j of 0 plus 2. That's where we're getting that 3 times 0 is 0 plus 2 is 2 from. So then we're going to take, this is where we started, so we're going to go all the way up to 6. So we need to do j equals 1. And again, substituting that in, 3 times 1 plus 2. And that gives us, 3 times 1 is 3, plus 2 gives us 5. And that's how we're going to continue. Continue with our j equals 2.
Oh, 8 and then 11.
There we go. Sometimes doing them in our head does pose an additional challenge. So be really careful. Because 3 times 2 gives us 6, plus 2 gives us 8. Yes, dear?
If we see like a pattern, can we just like keep on?
Yeah. Because once we get here, a lot of us are going, oh, wait a second, I figure out what's going on. So j equals 3 is going to give us what? 11. And our j equals 4, 14. J equals 5, 17. And then last one, j equals 6, 20. So now we need the sum of those values. The sum from j equals 0 to 6. So add them all up.
Please.
Yes. Should be 77.
Are we doing this all day?
No.
Please.
Boo.
But this is the first, like, this is section 10.1. This is, you guys do everything in 10.1. What's up? Building.
You're gonna somehow verify this?
No. No.
Verify using triggers.
We're going to do one more thing like this. I told you, this chapter is going to have very little trig in it. Very little.
Wait, so there is trig in this?
I do not guarantee that. I honestly have not looked that closely at it. I don't think so, but I'm not willing to make a guarantee. So here we go. Here's our last one like this before I show you the next bit. So we've got from k, the sum from k equals 1 to 6 of 3 over k plus 1. So we're going to do our, whoa, wrong pen. There we go. We're going to go from k equals 1. We're going to do our k equals 2, k equals 3, k equals 4, k equals 6. So those are all the pieces we need. So for k equals 1, we're substituting it in. We've got 3 over the 1 that we're substituting in, that's this guy, plus 1. So this one gives us 3/2. What's this one going to give us? Yeah, 3 over 2 plus 1. That's 3 over 3. That gives us 1. How about k of 3? 3/4. K of 4. Bless you. 3/5. 3/6, also known as 1/2. Either way's fine. And 3/7.
You round up, you get 600.6.
Hello?
A lot of rounding.
Okay, so then we're going to find the sum. We need to add those up. I was going to say you can either common denominator or we can put them in the calculator.
I don't know which path I'm taking.
3/2 plus 1 plus 3/4 plus 3/5 plus 1/2 plus 3/7.
Oh,
What do you have to say about
is this supposed to be like a big digit number? On the top? Let's see. Theoretically.
Theoretically, somewhere in the 600s.
Oh, 669.
Uh-huh. Yeah. Yeah, because we'd be getting to our common denominator, if we think about it, of, well, our 1/2s are going to cancel out, so we're going to have our 4 times 5 times 7. So our denominator is going to be 140 if we were to do it by hand and common denominator it. So our final answer when we put it in the calculator should be 669 over 140. So sometimes they're going to be fractioning gross. But that's okay, because we can do that. We have tools at our disposal. We do not have to do them by hand. You can do it by hand.
So
I could come in here and say, well, 3/2 plus 1/2, I know that's 2. Plus 1, that gives me a 3. And then all we'd have to add is 3/4, 3/5, and 3/7. So, like, that would be easier to do. But you don't have to. So, we have options. Okay? So, we're adding them up. Use the tools at our disposal. Questions on this bit? Okay, because now we're going to work towards the being able to write that equation. We kind of talked about them a little bit yesterday, writing our statements for any term. So our first type of equation we're going to have for this is our arithmetic sequence. Arithmetic. So what this means is if we look at our series or sequence, it's a plus. So when we moved from, on this one, when we moved from piece to piece, we noticed that this was plus 3, plus 3. Oops, jumped one. Plus 3. That's what I mean by an addition sequence. This was adding, right? So that would make this an arithmetic sequence. If we have something that's multiplying, like this guy was, this was times 3 times 3 times 3 between our different pieces. 3 times 3 gave us 9. 9 times 3 gives us 27. So this one is a multiplying piece, and we'll talk about that one later. So we're looking at the ones that have the adding between them. That's what these pieces are. So this is the way they write that. When we have a arithmetic sequence, I can find the next term by adding that same number. So when that one we did, I could plus 3 and find it without having to resubstitute in. That number we're adding is called the common difference, and we can find it by subtracting the pieces. So we've done this. We've looked at it like this. We're just giving it a name. So we're going to look at a sequence, and we're going to find the common difference. We're going to find how they're changing, and we're going to see how we can use that to write a rule. So just looking at these pieces first, we're going to figure out how it's changing. What is our common difference? What was it? Adding 5. Yeah, to get from -3 to 2, we add 5. To get from 2 to 7, we add 5. To get from 7 to 12, we add 5. So our common difference is 5. So I could write an equation for this. I could make a formula that says I can find my next term, my a sub k plus 1, by taking any term in our sequence and adding 5. We can do that. Let's look at the other one over here. And we're going to use this one in the next thing we do as well. Just want to look at this one again. See if we can find our common difference on this guy. Yeah. This is, they're getting smaller, so we're going to have a minus 3.5 or 3.5. Minus 3.5. So you could do this by taking 20 minus 16.5. That'll give you our 3.5. Or we could take 13 minus 16.5 to get there. So our common difference is minus 3.5. So if I want to get some term in my pattern, we can get a recursive definition by taking any term and subtracting 3.5. It'll give us our next piece. What's up?
What if it's like exponential?
That would be a different kind, and we're going to look at that in the next section. Yep. So this is just for the ones that would be adding. Because the exponential ones would be the multiplying bits, and that'll be in section 10.3. This one is actually the start of 10.2.
Oh, start, okay.
This is 10.2. Okay, so what we're going to be able to do from this is we're going to be able to take these kinds of sequences and be able to write these kinds of statements for them. That's our goal, is to be able to write them kind of like this. So what we're going to do is, instead of having them be a recursive definition, we're going to need to find a better one. So that I could say, if I wanted to find the 20th term, I didn't have to fill in everybody in between. I would like to be able to say, okay, plug in 20 for K or N and get that piece. So we're going to have a formula here. So for arithmetic sequences, to be able to get any term in the sequence without having to fill in the whole kit and caboodle, we can get our a sub n. We have two options here. If we're given the first term, we love that. We would have the first term plus n minus 1 times that common difference. That's what this D piece is here. It is our common difference. So we use this one if we're given a sub 1. Oftentimes we are, but not always. Sometimes we're just given a random term in the series. So if we're given anything other than a sub 1, we just call that a sub k. And all that is we can use that piece. It's just instead of having n minus 1, we'll have n minus k. It's the same common difference. So this works no matter which one we're given because it's the same thing here. But sometimes we're a little bit more comfortable with us not having too many letters in there. So what we're going to do is we're going to look at that second sequence we looked at to find our common difference. And we're going to find our formula, and we're going to find a term in it. So I highly recommend writing them down. If you only want to write down one, let it be the second one. So if you only want to write down one, put that one down. But we want to have these. I'm just giving us a second. Okay. So this is that same one we just looked at. The 20, the 16.5, and the 13. So we're given a sequence. This is our a sub 1. This is our a sub 2. This is our a sub 3. So we're trying to find the 15th term. Meaning I want to find a sub 15. We also are going to get an equation for a sub n. So those are their two goals right here. So we're going to start with the equation. I'm going to rewrite that 15 because that 15 looks weird. So I'm going to grab the equation that we just had on the previous page where I can have my a sub n that we get with our a sub 1 plus our n minus 1 times that common difference. What is our common difference on this thing? How is it changing? It's minus 3.5. This is the one that was subtracting 3.5 between each term. Okay, so we had 20 minus 3.5 to get 16.5. Minus 3.5 gets us down to 13. So we're finding how it's changing. So this is our common difference. That's this guy that goes right here. If we're looking for a sub 15, that means n equals 15. So we're going to have our value of a sub 1. We know that a sub 1 is 20. There's going to be 20 plus, we just said our n is 15 minus 1 times our common difference of negative 3.5. So let's simplify this because there's a whole lot in there. We've got 20 plus 15 minus 1, that's 14, times negative 3.5.
That's negative 980.
Plus.
Oh, okay, that's plus.
It'd be like, you got a very big number and it should not be that big.
Negative 29. You were right.
Negative 29.
No, like the multiplication part.
I was going to say just, yeah, it's like if you're doing it in pieces, that's totally fine. I was just saying we should wind up with negative 29. Okay, and I could do this with any of our terms. I could set this up using our a sub n equation, and I could use a sub 2. I could use a sub 3. Any of them will work. When we're writing our a sub n, our kind of generic version, all it is, instead of substituting in a 15, we're going to substitute in n, and we're going to wind up with an equation. So with a sub n, I'm going to use that same kind of setup. Our a sub n is going to equal our a sub 1. So I'm going to put my 20 plus our n minus 1 times that negative 3.5, which is technically correct, but not very good math grammar. Let's simplify this a little bit. What can we do to simplify this?
20 and minus 20.
Good distribute.
20 plus negative 35.
Multiply this guy out. Do this distribution.
Right, plus, never mind.
So we've got our a sub n equals our 20. N times minus 3.5, we get minus 3.5 n. Minus 1 times 3.5, we get plus 3.5. A sub n. What are we going to get as our equation when we finish this out?
Negative 3.5
Mm-hmm.
plus 23.
Plus 23.5. So this is how I could find absolutely any term. So if I wanted to find term number 4, I could. If I wanted to find term number 400, I could. Yes, dear.
Why is it negative 3.5 plus 23?
Oh, and negative 3.2. Sorry. I got excited. I dropped my n. It's this part. I will fix that so that it's fitting better. There we go. Boop. All right. Gotta have them in there. Because then if I wanted to find a sub 20, I could substitute that in for n. If I wanted to find a sub 352, I could substitute that in for n. We can find any piece we want to. Okay? Let's look at another one. Similar kind of vibe. So I'm giving us a sequence. We're going to find the 5th term. We want to find the 10th term. And we want to write the equation for the nth term. So let's take a look at this one. Our sequence goes from 2, 6, 10, 14. Yeah, our common difference, how it's changing between them, is going to be 4. Because we took 2 plus 4 gets 6. Or you can do 6 minus 2 to find your 4. Either way, however you think it works for me. But our common difference is 4 because we're adding 4 every time here. Plus 4. So it's going to keep going like that.
Do we find the equation first?
You can, or if you want to find 5th term, 10th term, and then do nth term, that's totally fine. If you want to do your nth first, that's totally fine. I was going to say, I sometimes think it's easier because there's a lot more simplifying in the nth term. So I sometimes think it's easier to just do our 5, then 10, then n. But if you like the n and then sub and plug, that's totally fine. So I'm going to go with doing 5th and then 10th, but you should get the exact same answers if you do it the other order. So we're going to find n equals 5 so that we find our a sub 5. That's going to be our first goal. So if we want to get the value of a sub 5, what's up? Okay. Yeah, so we can take our first term, our a sub 1, and use that guy. 2 plus our n, which is 5, minus 1, times our common difference of 4. So we'll have our 2 plus 4 squared, or 2 plus 4 times 4. So 2 plus 16, so we get 18. Yes, but I'm going to on purpose show it using the other equation, not just using A1, because everything we've done started with A1. So on this one, when I do our 10th term, when we do our A sub 10, I'm going to on purpose not use A sub 1. Let's use A sub 3, just because I can. Because I can. Sometimes we're not given our first term. Sometimes we're just given a random term, where they'll see A sub 4 equals 12. Find this next bit. So if we have not the first term, I can still use those equations. I can still take my A sub 10. It just means I'm going to use this guy instead of my A sub 1. So I'm going to put my 10. And when we have our parentheses where we had before our n minus 1, we're going to have our n, that's that 10, minus whatever number this is in the series, 3, times that same common difference of 4. So you don't have to use the first term. We can use whichever one we want. It would be the exact same answer if I switched the 10 out for a 2 and the 3 out for a 1. So this is just using A sub 3 because we can. Don't have to, but we can.
Wait, so the added number would be the number that's substituting for the n minus 1 is the same?
Say it again, just because I didn't process it.
So, like, for example, on this one's 10
Mhm.
plus parentheses 10 minus 3. Would those two first numbers be the same?
So this number and this number are the same.
Okay.
This was a not good choice. This 10 and this 10 are the same.
Oh.
So I will note not to do 10 and 10 on the next one. Yeah, if I had switched this out for using the second term, if I had done 6, it would have been a 6 here and a 2 here. Because I would have used 6, and this is our second term, so this would have been 2. So 6 and 2 would do this. I could use our 2 and our 1. I could use 14 and 4. Any of them work. I just picked it and did not compute the fact that I had 10 in 2 different places from 2 different meanings. So when we simplify this one, we're going to have our A sub 10. And we're getting from our 10 plus 10 minus 3 is 7 times 4. So what is our value of A sub 10? 38. Whether you did it with A sub 1 at the beginning or A sub 2 or A sub 3 or A sub 4, you should get the same value, no matter what. So let's find A sub n, our generic-y version. So we're going to take our A sub n. I'm going to give us a little barrier because those are too close together for me. Maybe. There we go. So we're going to find A sub n. And we do that by just using the letter n instead of having that number. You can use our A sub 1. You can use any of the options we have. We tend to use 1 for it just because it's easier multiplication-wise. But you don't have to. We could do this with A sub 2. I could do it with A sub 3. We'll wind up at the same equation. But typically we do use the A sub 1 if we have it. So we're going to take our A sub 1 value, which is 2, plus our n minus 1 times that common difference of 4. What's up? Okay. I'm just old. You're talking fast and mumbling, and I caught nothing. Because I am old and have old lady ears. I'm just saying.
You have good hearing. But sometimes we say
Every now and then. There's you gotta remember, I have a teenage boy, so there are certain words that my ears will just pick up on like a radar. My oldest is 13, so I know I'm like just over a year from having my oldest here. He's about to finish 7th grade.
You gonna teach him?
Terrifying. Probably not. There's enough math teachers here. I should not have him in my class.
Walk him inside real quick.
It's an ethical question. I'm not saying it hasn't happened, but it is tried. We try to avoid it really hard, teaching your own child, because there's bias issues. Granted, I would probably be harsher on him than anyone else, but it's an issue of fairness. We wouldn't want to give like preferential treatment, accidentally tell embarrassing stories, whatever. Dude, he's my child. He is exactly as weird as I am. No. Our energies feed off each other. It's insane. Whatever. All right, so, I'm not going to use the yellow. That's really hard to read. So our a sub n, let's get our simplified equation here.
4a minus b.
Huh?
4a minus b.
He jumped ahead, but yes. So we're going to start by multiplying this out, doing our distribution. 2 plus 4n minus 4. Simplify this out, a sub n, we get 4n minus 2. So again, if you go back here and check these, if we went a sub 10 and we came into this guy, 4 times 10 minus 2, we get exactly 38. With the 5, 4 times 5, 20, minus 2 gives us 18. So it's the same exact pieces. It's just that this guy was working it based off of our terms. This guy is giving us a kind of general. Okay? Questions on this one? Actually, that was the last question.
Oh, really?
So,
Wrap it up.
I was gonna say, because we're like the pace we're moving at a very good pace. I'm totally cool with that. So we've got a little over 5 minutes. Look at 10-1. You guys can do absolutely everything on it. If you haven't finished it, now's a great time to look at it, see if we got any questions on it. I'm gonna work on passing some stuff back to you because my piles are getting a little overwhelming again. But work on stuff, ask questions. I'm happy to help if you got them. But it's one of those things that we're moving at a pace I am happy with, so we don't need to push.
Can we go ahead?
No. So the quiz is next Thursday, right?